For over 6 decades, metformin has been a go-to medication for managing type 2 diabetes. But a recent discovery has turned heads. This seemingly straightforward drug also has a surprising impact on the brain. For years, scientists have understood that metformin helps control blood sugar, but the exact mechanisms behind its effectiveness remained somewhat mysterious. Now, a groundbreaking study suggests a significant part of its action happens directly in the brain, opening exciting new avenues for treatment. Researchers at the Baylor College of Medicine in the U.S. have pinpointed a specific pathway in the brain that metformin seems to utilize. This is in addition to the known effects of the drug on biological processes elsewhere in the body. It's been widely accepted that metformin lowers blood glucose primarily by reducing glucose output in the liver, explains Makoto Fukuda, a pathophysiologist at Baylor. Other studies have found that it acts through the gut. We looked into the brain as it is widely recognized as a key regulator of whole-body glucose metabolism. We investigated whether and how the brain contributes to the anti-diabetic effects of metformin. But here's where it gets controversial. Previous research by the same team had identified a brain protein called RAP1 as playing a role in glucose metabolism, particularly in a region of the brain called the ventromedial hypothalamus, VMH. The 2025 study revealed that metformin travels to the VMH in mice, effectively turning off RAP1 to combat type 2 diabetes. When the researchers bred mice without RAP1, metformin lost its impact on a diabetes-like condition, even though other medications still worked. This is strong evidence that metformin operates in the brain through a distinct mechanism compared to other drugs. The team also carefully examined the specific neurons affected by metformin. This could pave the way for more targeted therapies that focus precisely on these neurons in the future. We found that SF1 neurons are activated when metformin is introduced into the brain, suggesting they're directly involved in the drug's action, Fukuda notes. Metformin is a well-established drug, considered safe, long-lasting, and relatively affordable. It works by reducing glucose production in the liver and boosting the body's insulin efficiency, thereby managing type 2 diabetes symptoms. Now, the discovery of its brain-based action adds another layer to its effectiveness. And this is the part most people miss. This finding could lead to ways to enhance metformin's effects, making it even more potent. It's also connected to other studies showing that metformin might slow brain aging and increase lifespan. This discovery changes how we think about metformin, Fukuda emphasizes. It's not just working in the liver or the gut, it's also acting in the brain. We found that while the liver and intestines need high concentrations of the drug to respond, the brain reacts to much lower levels. What do you think? Does this new understanding of metformin's actions change your perception of the drug? Could this lead to even broader applications in the future? Share your thoughts in the comments below.